All right, so I'm just going to have a go at question 2b. Calculate the total mass of the solid mixture needed to inflate a 60 decimeter cubed airbag at room temperature and atmospheric pressure. So this is where we need the ideal gas equation. So I've got that here. PV equals nRT, and I've just rearranged that to give us number of moles, because obviously then from the number of moles we can work out the mass using the MR. Information that we've got in the question, we have the volume. Okay, we're given that as 60 decimeter cubed. All right, so we need to change that into meters cubed. We're told atmospheric pressure, which is 101,000 pascals, and we are told it's room temperature, which is 298 Kelvin, and you get given the ideal gas equation. All right, so the only one we've got to change there is the decimeter cubed, and I'm going to times that times 10 to the minus 3 to give us it in meters cubed. Get rid of that little decimeter cube there. So when you do that, you should get, and put that all into your calculator, you're going to have 101,000 multiplied by 60 times 10 to the minus 3 over 8.31 times 298, which equals 2.45 moles. Okay, and just remember that that is the moles of nitrogen. Okay, so from that you can work out the mass of nitrogen. So you've got the number of moles. Nitrogen, the MR of nitrogen is 28 because it's N2. So the mass of nitrogen that is produced in 60 decimeters cubed of nitrogen equals 28 times 2.45, which equals 68.6 grams. All right, so this is where we're going to use some lovely ratios, and we've got to go back to the question bit from before, because that tells us the mass of nitrogen, but the question isn't asking us that. The question is asking us calculate the total mass of the solid mixture, and the solid mixture, remember, is the sodium azide and the potassium nitrate. Okay, so needed to get that much. Now, if we go back to what we did earlier, I've got that here. We know from those equations that 10 moles of sodium azide produces 10 moles of sodium, which reacts with 2 moles of potassium nitrate. Now, what we've got to work out now is how many moles of nitrogen are produced. So if I have 10 moles of sodium azide and I make 10 moles of sodium from that, I will also produce 15 moles of nitrogen. I hope you guys can see that. Just using the molar ratio, 2 to 2 to 3 is the same as 10 to 10 to 15. Okay, but that isn't all the nitrogen that's produced, because over here we are also producing 1 mole. Okay, so if we start with 10 moles of sodium azide and 2 moles of potassium nitrate, together we will have 15 plus 1 moles of nitrogen produced. So if we have that 10 moles there, 2 moles there, the ratio is to 16 moles of nitrogen. Okay, so earlier we worked out 10 moles of sodium azide had a mass of 65 grams. 2 moles of potassium nitrate has a mass of 202.2 grams. So together, that mixture was 267.2 grams. That would produce 16 times 28, remember the MR, just using this again, look, mass here, number of moles times MR, would produce 448 grams of nitrogen. So what that thing is saying there, that from the 267.2 grams of the mixture, you would produce 448 grams of nitrogen. However, in the calculations that we've done before, we know we're making this mass of nitrogen. So here's where we use the ratio. I'm going to go back up to here now. I'm going to do mixture to nitrogen. Okay, so we know from our calculations that 267.2 grams of the mixture produces 448 grams of nitrogen. Look. We know from our earlier calculation that 60 decimeters cubed of nitrogen is 68.6 grams of nitrogen. Okay, so the question is, how much mixture, what mass of mixture here produces 68.6 grams of nitrogen? And this is just working in ratios. What I would do here, if I were to have a calculator, I'd divide both sides. So I divide that by 448 to get 1 gram of nitrogen. And then whatever I do on one side, I do to the other. So 1 gram to 68.6, I multiply by 68.6. Same on this side. The first thing I'm going to do is divide 267.2 by 448. Then I'm going to multiply it by 68.6. And I still, unfortunately, don't have my calculator, but I think from my answers earlier, that is 40.9 grams. And that is the answer. Okay, the answer to the question, we just have a little look at it again. Calculate the total mass of solid mixture needed to inflate 60 decimeters cubed. Working back, the answer is 40.9 grams of the mixture.